Welcome to another exciting episode of AI Frontiers, the podcast dedicated to exploring the cutting edge of artificial intelligence research. Today, the focus is on a remarkable collection of 117 research papers published on June 10, 2025, under the category of Computer Science Learning, titled AI Unleashed: Machine Learning Breakthroughs. This episode will dive into the innovations shaping technology and society. Let's embark on this journey of discovery together and uncover the future of learning algorithms. Let's begin with an overview of what lies ahead in today's episode. This presentation will explore the dynamic field of machine learning through the lens of 117 newly published papers. Key themes driving innovation and offering real-world solutions will be uncovered. Groundbreaking findings and the methodologies behind them will be highlighted. 3 seminal studies with the potential to transform the landscape of AI will be spotlighted. Finally, future directions will be discussed, examining how these advancements might shape tomorrow. The stage is set for a deep dive into the latest developments, so let's get started with the foundations of this rapidly evolving field. To set the context, let's take a closer look at the field of computer science learning. At its core, machine learning is about teaching computers to learn from data and adapt without explicit programming for every task. This technology powers everyday tools, from Netflix recommendation algorithms to the sophisticated systems behind self-driving cars. The primary goal is to address real-world challenges in areas such as healthcare, climate solutions, and beyond. The sheer volume of research, 117 papers released in a single day, demonstrates the field's explosive growth. As the backbone of modern AI, machine learning holds limitless potential to transform how complex problems are solved. This foundation paves the way for understanding the specific innovations in focus today. One of the dominant themes emerging from this batch of research is the advancement of large language models, with a particular emphasis on efficiency and ethics. These models, which power text generation in chatbots and virtual assistants, are being refined to operate with fewer resources. A significant focus is on the concept of unlearning, where sensitive data is removed from a model's memory without the need for complete retraining. Research by Ren and colleagues highlights the persistent challenges in truly erasing such information, raising important questions about privacy. This work is crucial for ensuring user trust and compliance with data protection laws. As AI becomes increasingly integrated into daily life, addressing these ethical concerns remains critical for responsible development in a data-driven world. Another key area of research centers on time series forecasting and multimodal learning, both of which push the boundaries of data prediction and integration. Time series forecasting focuses on predicting future trends in sequential data, such as weather patterns or stock prices. Innovations by Zhuang and colleagues have led to efficient models that deliver remarkable accuracy in these predictions. Meanwhile, multimodal learning combines diverse data types, like text, images, and sensor inputs, to provide deeper insights. In biology, for instance, such approaches have significantly improved disease outcome predictions. Central to these advancements are neural networks, which excel at identifying hidden patterns in complex datasets. These developments hold immense potential for solving intricate problems across various domains. Reinforcement learning and interpretability represent 2 additional themes shaping the current landscape of machine learning research. Reinforcement learning enables AI systems to learn through trial and error, proving invaluable in fields like robotics and gaming, where complex tasks must be mastered. Meanwhile, interpretability addresses the challenge of understanding the often opaque decision-making processes within AI, often referred to as the black box problem. Building trust in these systems is essential, especially in high-stakes areas like healthcare. Recent studies have also demonstrated faster training outcomes by prioritizing uncertainty over mere errors. Together, these focus areas underscore the dual need for advanced learning techniques and transparent, reliable systems in critical applications. Turning now to some of the most impactful findings from this collection of 117 papers, several breakthroughs stand out for their immediate relevance. Research by Ren and colleagues on unlearning in language models reveals lingering privacy concerns, as many techniques fail to fully erase sensitive data. Zhuang and team have achieved new accuracy benchmarks in weather forecasting, potentially transforming disaster preparedness. multimodal models are enhancing disease prediction in biology, offering hope for personalized medicine. In reinforcement learning, a focus on uncertainty has accelerated training and improved outcomes. Lastly, new interpretability tools are fostering trust in AI for high-stakes decisions. These discoveries are not just academic milestones, they represent tangible steps toward addressing pressing global challenges with smarter, more accessible technology. Behind these impressive findings are innovative methodologies that drive progress in machine learning research. Transformer architectures, initially designed for language tasks, are now widely applied to connect distant data points across various domains, though they often require careful optimization for efficiency. Reinforcement learning relies on a system of rewards and penalties to enable dynamic learning in unpredictable environments. Self-supervised learning offers a cost-effective approach by extracting patterns from unlabeled data, reducing reliance on expensive labeled datasets. Additionally, data imputation techniques address gaps in messy real-world datasets such as health records, ensuring robust analyses. Each of these methods, while powerful, comes with unique strengths and challenges that researchers continuously refine to push the boundaries of what AI can achieve. Let's delve into the first of 3 standout papers from this collection, titled SOC, Machine Unlearning for Large Language Models, authored by Ren and colleagues in 2025. This study surveys techniques aimed at erasing specific data from language models without the need for full retraining, a critical issue in privacy protection. The findings reveal a concerning limitation. Many unlearning methods merely mask sensitive information, rather than truly removing it from the model's memory. Selected for its sharp focus on ethical implications, this paper underscores the importance of user trust in AI systems. It serves as a wake-up call, urging the development of scalable solutions that ensure genuine data removal. This work highlights the intersection of technical innovation and societal responsibility, making it a pivotal contribution to the field. The second highlighted paper, LaDCast, a latent diffusion model for medium-range ensemble weather forecasting, by Zhuang and colleagues in 2025, tackles the vital challenge of weather prediction. This research introduces a diffusion model that starts with random noise and refines it into accurate forecasts within a compressed latent space, significantly reducing computational and storage demands. Matching the accuracy of leading standards, such as those set by the European Centre for Medium-Range Weather Forecasts, LaDCast excels even in predicting extreme events like cyclones. Chosen for its real-world impact, this study could enhance disaster preparation and resource management, particularly in under-resourced regions. It demonstrates AI's ability to address chaotic, high-stakes challenges, offering a glimpse into how such technology can save lives and improve global resilience. The third notable paper, GSIM, Generative Simulations with Large Language Models and Gradient-Free Calibration, by Holt and colleagues in 2025, explores innovative simulation tools for high-risk decision-making. This approach combines the creative power of language models to define simulation rules with real-world data calibration through gradient-free optimization, enabling safe testing of what-if scenarios in fields like healthcare and logistics. In simulated environments, GSIM has delivered precise predictions for critical decisions, such as optimizing hospital bed allocation. Selected for its unique blend of creativity and practical validation, this work opens new possibilities for safer, smarter planning across industries. It represents a forward-thinking approach to merging imaginative AI with grounded data, paving the way for transformative decision-making tools. Looking ahead, the future of machine learning, as reflected in these 117 papers, points to several critical directions. The development of unified frameworks that integrate diverse learning approaches, such as combining language processing with decision-making capabilities, appears essential for broader progress. Reducing computational costs remains a priority to ensure AI accessibility for all, from large organizations to individual developers. Strengthening robustness against errors and malicious attacks is another urgent need, especially as AI systems take on life-critical roles. Moreover, embedding ethics, focusing on privacy and fairness, into the core design of AI rather than as an afterthought, is non-negotiable. Envision a future where AI evolves into a trusted partner, balancing unparalleled brilliance with unwavering responsibility. These goals chart a promising yet challenging path for the field's evolution. A brief note on the creation of this presentation reveals the role of advanced technology in synthesizing such content. This episode was crafted using AI tools like GPT-Grok, specifically the Grok 3 model for content synthesis. Text-to-speech narration was powered by DeepGram, ensuring clear and engaging audio delivery. Visual elements were supported by image generation tools from OpenAI, enhancing the overall experience. While the content has been reviewed by a human expert, minor oversights may still exist. For transparency and further exploration, all references to the discussed papers are provided in the show notes. This behind-the-scenes glimpse highlights the synergy of human oversight and AI innovation in bringing complex research to a wider audience. For those eager to stay updated on the latest in AI research, an invitation is extended to subscribe to the AI Frontiers YouTube channel. Titled simply AI Frontiers, this platform serves as a dedicated source for cutting-edge insights and emerging trends in artificial intelligence. By joining this community, access is granted to content that explores the technologies shaping tomorrow. Subscribing and enabling notifications ensures that no update is missed, from groundbreaking papers to thought-provoking discussions. Engagement with AI Frontiers offers a front-row seat to the advancements driving the future of technology, so consider becoming a part of this growing network today. Thank you for joining this deep dive into the latest machine learning research on AI Frontiers. To recap, today's discussion highlighted how efficiency, ethics, and real-world impact define current AI advancements. Listeners are encouraged to explore the referenced papers for themselves. Links are available in the show notes, and to share thoughts using the hashtag AI Frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses content from the arXiv preprint server under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.